Okay. Hello, everyone. Thank you for joining to the April edition of the Kubernetes Monitoring Helm Chart Office Hours. I'm Pete Wall, one of the engineers that builds the Kubernetes Monitoring Helm Chart at Grafana Labs. And I am excited to show what we've been up to. We skipped the March edition, so we've got 2 months of stuff to cover, and the agenda looks actually quite similar. There's been a lot of work going on behind the scenes. But I'm excited to share a little bit of what's happening in the 2.0 branch, or the main branch for releasing 2.0, and then the version 2.1 that's coming up very soon. Give some updates on that, including some more internal details about how we're going to be building that and how that's actually going to look when you deploy that onto your clusters. And then always we'll have time for questions and answers at the end. So Kubernetes Monitoring Helm Chart V2, what's been happening in the last 2 months. This is a very short summary, but I wanted to just highlight a few of the big things that have happened for the last 2 months. The pod logs feature, we introduced an experimental option for gathering pod logs using the file log receiver. File log receiver comes from the OpenTelemetry community, and it has support inside of Grafana Alloy. So using file log has a couple advantages or a couple options that people really enjoy. It gathers the log data in the OpenTelemetry format. And so if you want to keep all of your stuff in the OTel format, this is a way to do it from the very start. The other advantage of that is that you can connect the logs that come from the file log receiver with the k8s attributes receiver. So that means you can enrich your log data with a lot of information about the Kubernetes artifacts that generated it. It is experimental. There's still some things that we want to refine and change about this one. So feel free to use it, but we do reserve the right to change some of the way that gets implemented and potentially even break some of the interfaces for that. But a lot of people have been excited about that. So let me know if this is something that's interesting to you. And if you use it, please send us feedback. The next one for cluster metrics, we added the easy way to get prober metrics. So the kubelet also exposes metric endpoint for probes. Think of the liveness probes and readiness probes that are on your Kubernetes resources. If you want to capture metrics about the health and success rates of those metrics, we have something inside of the cluster metrics feature that can automatically find those, scrape those, deliver those up to wherever your metrics destination is. Another change that we did I think this was just a few weeks ago. Right now, for the longest time in 2.0, we tried to be smart with placing the destination components. So with the Helm chart, you can define your destinations, and it's an array. We tried to be smart with placing the Alloy components, the component config for those destinations onto the Alloy instances that were using it. And so the metrics destinations went onto the places that were generating metrics. The logs destinations went onto the Alloy instances that was generating logs. And we tried to not put destination configs on things that weren't using them. Often in computer science, the more you try to be clever, the more it actually causes problems. We decided to just say all destination components are going on all Alloy instances. And what's the big advantage for this? The main advantage is that if you use the extra config section, or if you do some other config modification that you now reference a destination that wouldn't have been placed there before, there was no way to force the Helm chart to say, I really want this destination config to be on this Alloy instance. You just had to redefine it, I guess. So now all destinations are available to you. What's the overhead of this? There's going to be a minimal memory overhead just to load the config components, but if they're not being used, there should be no CPU hit or anything like that. They'll just sit there idle. If you run into issues, I know we've seen some people had an issue with an upgrade. If you run into issues, please let us know in the Kubernetes Slack channel or file an issue in our GitHub. We've been really hard at work adding lots more integration and platform tests. I strongly believe in test automation. Not only does it create living examples of how to use the Kubernetes Monitoring Helm chart, not only are they great examples, but they are examples that we exercise all the time, several times a day, in fact. But these tests help us verify the development that we're doing so that it actually works under the configurations that we expect. So we added an integration test for application observability. So using the app Ollie feature, generating the host info metrics and making sure that those are generated and delivered correctly. Using Argo CD to deploy the Kubernetes Monitoring Helm chart. So as an alternative deployment without using the Helm CLI. We added an integration test to understand better how OTLP translation works. So you gather your metrics with the Prometheus style, you gather your logs with the Loki style, and then you deliver them through the OTLP destination through like the OTLP gateway. What happens to the labels when they get translated into attributes? We added a new integration test to do patch level upgrades. So this is, something.something.n-1 to the current version. And so we wanted to make sure that upgrading from a previous patch release to the current release, there's no surprises there. When 2.1 releases, we'll also include one that goes from the minor upgrade release. So something.n-1 to 2.1. And then finally, we've added platform tests for EKS Fargate. So clusters that use Fargate nodes, how do those interact with the k8s monitoring Helm chart? And then also deploying using the EKS add-on. We do publish an add-on to the EKS marketplace. That one is based off of version 1, so just be aware of that. But we wanted to add some test automation so that we know that deploying using the add-on is as reliable as any of our other deployment methods. As always, tons of dependency updates. The Alloy Helm chart itself just released 1.0.2, so we are including that. Lots of updates to kubestate metrics and Node Exporter and Windows Exporter and all of those things, and we stay on top of those usually a day or two after they get released to the public. And then also lots of bug fixes. All right, so version 2.1, where is this going? We've been talking about it for a long time, and I just want to give an update on what we have planned. I was really hoping to have it released this week, but we're taking a little bit more time to make sure that everything is working the way we expect it to. So hopefully by next week, we'll have it released. But I want to highlight the key features that we're going to be including in 2.1. Alloy operator. 2 months ago when we talked about this, it was called dynamic alloy deployments. And now we're calling it out. There's an alloy operator. And I'll talk a little bit about that in the next slide. Also in 2.1, tail sampling, service graph metrics, and then we're going to be adding some more service integrations into the integrations feature. So what is the alloy operator? So on the left side, this is how we deploy Alloy instances today. We have the Kubernetes Monitoring Helm chart, which is a Helm chart, and it actually bundles the Alloy Helm chart and deploys 5 copies of it, potentially, based on what features you've enabled. This has been working great, but by the nature of how Helm works, we have to define all of the things we want for the Alloy Helm chart at the in the values file. So if you look at the current 2.0 values file, I want to say it was something like 80% of the lines were dedicated to just defining Alloy of the different Alloy deployments we have there. And that's a lot. And especially when a lot of effort went in when making 2.0 to reduce the values file into just the things that you care about. There's a lot that's going into defining Alloy instances, and I feel like that kind of overwhelms when people start to look at it. And so one of the things that we're doing with 2.1 is trying to do, to an extent, do for the Alloy instances what we did with destinations. Show what you need to know. Show what you are interested in being able to do. Don't remove any of the functionality. You'll have still all of the ability to customize and tune the Alloy deployments, but not have to show every single switch and feature at the top level. So instead, in 2.1, we are not going to be using the Alloy Helm chart directly. We're going to be using the new Alloy operator Helm chart. It's a new project that we're building. And what this allows us to do is it creates a custom resource definition for Alloy. And then the k8s monitoring Helm chart will then deploy Alloy kinds, so instances of the Alloy kind. And that then with the operator will deploy the Alloy instances basically identically to how they were before. My goal is an upgrade from 2.0 to 2.1 will look seamless. It will result in the same pod footprints and everything like that, and all the things will work exactly the same. It's just the method by which these Alloy instances get deployed will look a little different. So why are we doing this? What's the advantage? First off, like I said, it reduces the overhead of the values file. It kind of condenses it down to the things that you care about as users of the Helm chart. It also allows us to do a little bit more dynamic deployments of Alloy. And here's a great example. One of the things that we're going to include in 2.1, if you are using the application observability feature, you know that one of the things you do, you enable the feature, app ollie enabled true. Then you get an error message that says, hey, if you want to use app ollie, you got to turn on a receiver. So you go app ollie, okay, receivers, OTLP or gRPC enabled true. And then it goes, hey, if you want to use gRPC, you need to open up the gRPC port on the Alloy instance. And you're like, oh my gosh, this is now the third error message. So, okay, Alloy receiver, extra ports, gRPC is on. Now what we do, since we have much more control over the Alloy deployments, when you enable the gRPC receiver in the app ollie feature, we'll automatically open the port. We have the ability to do that now. So there's going to be much more of a rich interaction between the features that you enable to the deployment that actually enables those features to work. So I'm really excited about this one. This one's really cool. One of the other main reasons why we wanted to do this is that for the next big feature, so for tail sampling, it's really going to come in handy. So I wanted to show a little bit of how tail sampling affects the deployment of the k8s monitoring Helm chart and of the topology on your clusters. This is kind of how it is today. If we enable the application observability feature, you get Alloy receiver. Apps on your clusters will send their traces to Alloy receiver, which we do some processing in our pipelines, and then we deliver them to Tempo to store the traces. When you enable the tail sampling, what we'll do is we'll automatically, this will be invisible to you, we'll automatically deploy another Alloy instance called the Tempo sampler, and this will be tied actually to the destination. So you can enable tail sampling rules per destination if you have different ones based on where you're sending them to. And a potential use case for that would be if you have Tempo OSS locally deployed on your cluster, you want to send all of your traces there, but then you want to send just a subset of the traces to off-site storage or something like that. You'll be able to define different rules for different trace destinations. So in this case, we will enable the tail sampling on the Tempo destination. And so automatically, the k8s monitoring Helm chart will deploy the sampler. We'll configure the pipeline in there to do the tail sampling rules. And then we will rewire the destination from Alloy receiver to the sampler. And then the sampling rules will take effect there. And then finally forwarding off to the original destination that you specified. I didn't have the values file snippet that would enable this at the moment, but for the most part, it will be 2 or 3 lines. Tail sampling enabled true, and then here are the policies that I care about. So we're hoping to bring the same level of ease and delightfulness of enabling this previously complex feature into k8s Monitoring 2.1. The other big feature that we're adding to this was service graph metrics. This will behave similarly, but just slightly different. So service graph metrics will be an additional feature for the application observability feature. It's not tied to the destination. So in this example, app ollie, connectors, service graph enabled true or something like that for the values. And so then what will happen is traces will be both sent to the destination as well as to a service grapher Alloy instance that, again, we're going to be deploying because we'll have the ability to dynamically deploy Alloy instances. And then service graph looks at the traces that are generated from all of the apps on your cluster, and then it generates metrics about them. And so you can see then what will be really interesting is that the new Alloy, the service grapher, will accept these traces, it'll generate metrics, and those metrics will then be forwarded to a metrics destination that you have in your list. And so in this case, it's Mimir on Grafana Cloud, but it could be a locally deployed Mimir or a locally deployed Prometheus or anything like that. Definitely, you can use both of these features together. So you could deploy service graph metrics. You could also deploy tail sampling together. and we'll automatically wire all of these things together in the way that we know how. I'm really glad to have Robbie Langford as a part of the k8s Monitoring Helm chart team. If you've used the Grafana sampling Helm chart that's in our Grafana Helm charts repo, he is the original author of that one. And so I've got a great support and knowledge in Robbie to help make sure that all of this stuff is implemented the correct way. So I'm really excited about that. And again, because both of these features deploy new Alloy instances, what we really didn't want to have is to have a 6th and a 7th Alloy in the values file, and it's just going to get ridiculous. And so getting the ability to use the Alloy operator to dynamically create and deploy these Alloy instances really gives us the flexibility to deploy these features with the simplicity that you expect, as well as the full-featured and scalability that you expect to. So again, here's the summary of what we have planned. Alloy operator, tail sampling, service graph metrics, and a few more service integrations. Again, we're trying to target this for next week, so keep your eyes open. And that's the end of the prepared stuff. So I'd love to open it up for questions and answers at this point. So just feel free to unmute, ask your question, raise your hand, or ask it in the chat. Right on. All right, I'm going to take a drink of coffee.
So maybe I have a question, Pete. Hi, Basti here from the Solutions Engineering team. When we do sizing for customers, we often struggle that they send the data to us. Have you ever thought about a configuration where we would just do like some sinkhole configuration that we have where no metrics are sent to Grafana Cloud, but we would be able to get the information from the Alloy instances running about how many metrics would we be sending, and we just have a sinkhole configured that where we just have a dry run and we don't need to do a full-blown POV with the customers just to get the sizing done correctly.
I see. That's a really great idea. So let me restate just to make sure I understand what you're saying. You want to be able to deploy the k8s Monitoring Helm chart with all of the features that you eventually want to use with the customer, but rather than actually delivering the data, the metrics, logs, traces, profiles to a destination for storage, you want to send them to some sort of intermediate, like a metering thing that measures, understands the full active series, the full DPM, and then you can get an estimate of that. And then you can decide, okay, do we need to tune this further, or do we need to, or is this good? And we just turn it on for real destinations.
Actually, my thought was about Alloy will have the information how many metrics it has scraped.
Sure.
So this internal metrics, they can be forwarded, but everything else, just like have a relabel rule, just drop it.
Yeah.
You know the Prometheus relabel rules that helps you just dropping the data before sending it,
Right.
and just keep the stuff, the internal like scrape sample scraped, all that stuff,
Yeah.
and just have it like in a dry run mode or in just an estimation mode or whatever we call it.
Sure.
So
yeah. That's a cool idea. So basically like a null destination. And so all things can go to that, but then you can use the Alloy's own internal metrics to get the information that you need.
100%, yeah.
I like that. Yeah, we should definitely be able to do something like that. Let me make an enhancement ticket on the GitHub, and then I'll send it to you and make sure that it's capturing your ideas right. And then it shouldn't be too tricky to implement something like that. It's a great idea.
Thanks.
Yeah, any other questions?
I'm just starting to use the auto instrumentation with Beyla. I don't know how to pronounce it in English.
No, you got it. Yeah.
Beyla. And I was wondering if, because I've just started 30 minutes ago and testing, does the OLT, do I need only one destination, which is OLTP, and so it can send the metrics, the logs, and the traces? Right. Or if because at the moment, the way I have defined my destination is I have one destination for trace, one destination for metrics, and one for logs. Mm-hmm. If I, at the moment, have given him the 3 destination, will it work? Because I don't know yet if it's working.
Sure.
But, okay.
Yeah. Okay. No, that's a great question. So, and there's 2 things that I'm going to highlight from the Helm chart based on that question. So thank you for the question. What does Beyla need? What sort of destinations does it need? So Beyla, when you pair it with the application observability chart or feature, sorry, it will generate both metrics and traces based on the applications that it finds on the cluster. It will automatically find applications and scrape those or generate information, automatically instrumented. That's what it does. If you so what it will do is it will generate metrics. Those metrics get scraped by Alloy metrics, and then those metrics are in the Prometheus format. So my recommendation is to keep a distinct destination in with the Prometheus type. That way you don't have any issues with translation from the Prometheus format metrics into OpenTelemetry. It also generates traces, and those traces are directly sent to the Alloy receiver instance. And those ones are in OpenTelemetry format from the beginning. And so I would recommend keeping your 3 distinct destinations, one for the metrics, the logs. I don't believe that there's application logs that get generated from Beyla, but one for the traces. And so that way everything kind of stays in the same ecosystem that where it was generated. The other point that I wanted to make, and I think this is a great time or a great segue into talking about this, is there's a little bit of a subtlety to the way that the Kubernetes Monitoring Helm chart assigns the destination to where to send the data based on where it came from. If in your Helm chart, in your destination list, you define, I've got a Prometheus type destination, I've got a Loki type destination, I've got an OTLP destination for traces, and then I also have an OTLP destination for metrics, logs, and traces, all 3 at once. Maybe it's an OTLP gateway or something like that. The way that the Kubernetes Monitoring Helm chart behaves by default is it will try to match ecosystem to ecosystem. So if you have metrics that are generated from Prometheus style things, so a Prometheus scrape, it will deliver them to the Prometheus type destination. It will try to keep it in the same ecosystem and not do translations. If you have metrics that are pushed to Alloy receiver, and so the metrics come in the OTLP format, we will keep them in the OTLP format, and we will prefer to send them to the OTLP type destination. We won't multiplex in this circumstance. There are, for every feature in the values file, you can manually specify the destinations and overwrite the default destination. So for cluster metrics or something like that, you could say, I want to send all metrics to both the Prometheus destination and the OTLP destination. And then we'll do the translation to OTLP for that delivery. So there's a little bit of a subtlety into that. There is a documentation in the Helm chart that explains the reasoning for that. It's trying to avoid the translation, which often is imperfect. So just be aware of that. All that to say, my recommendation is keep the distinct definitions, the destination definitions. And I think you'll find you'll get more out of the data that gets eventually stored into your destinations.
Okay, so from what you've said, I just got that Beyla just scrape, but it doesn't send the data. It sends the data to the Alloy receiver in OLTP.
Yes, yeah. Okay. So Beyla generates metrics and traces. The traces are pushed to Alloy receiver, which then gets processed and pushed to your destination. The metrics sit there and they're scraped like any other metrics source that you have on the cluster. So Alloy metrics will find them, scrape them, and then deliver them to your metrics destination.
Okay. Thank you.
Good question.
I still need to have a look at the example with all the traces. I'll try to understand what is done from traces to metrics, but
Yeah.
maybe that would be for another time.
Sure. Yeah. And you take a look and feel free to ask questions on the Kubernetes channel on the public Grafana Slack.
Okay.
And we'll be glad to help you out there.
Thank you.
All right. Any other questions? Good questions today. Great. Okay. My hastily added slide. If anyone here on the call live or is watching this later, if you're in the Minnesota area, I will be at Open Source North in St. Paul on May 29th. And so Grafana will have a booth there. I'm actually giving a talk. And so feel free to stop by, say hello, bring your questions there. I'd be glad to see you. And then finally, the wrap-up slide. Thank you, everyone, for joining. Again, we build this project based on community feedback. This project is meant to make your jobs easier. It's meant to deploy a really full-featured experience and solution for gathering observability telemetry data. And we try to make it so that it actually solves the problems that you're facing. So please bring us feedback, bring us comments, bring us the things that you want. Grafana.slack.com is our public community Slack, and we're often in the Kubernetes channel. Otherwise, our GitHub, Grafana /k8s-monitoring Helm, file issues, send PRs. That would be great too. But we really thank you for joining this community call, and have a great rest of your day. Take care, everybody.